Hello, my name is Barbara Bryant, and this is a presentation about my final project for Harvard Extension's Big Data Analytics course, and I focused on measuring anxiety in media reports. I was interested in whether we can measure sentiment from news articles and see how that changes over time, perhaps in response to world events, and then look at whether different publications have different levels of anxiety in their articles. The data that I used is from the GDELT project. It's a massive big data set containing almost a billion news articles covering 300 million events. The events include information about the main actors, the location, the date, of course, and then what type of event is it? There's 200 different categorizations of events. It also includes some impact on a country's stability, which is a score between -10 and 10, and how many news articles mentioned it. The article or global knowledge graph database contains information about news sources, including a cool analysis of emotion and theme, and that's called the Global Content Analysis Measure. In many cases, it is simply a word count of words relating to a particular type of emotion or theme that occur in the news article. I focused in on anxiety. So there's a list of words from the Regressive Imagery Dictionary that are associated with anxiety. I calculated a document score as the number of such words in the document divided by the total words in the document. I found an article from Pew Research that placed various news sources on a spectrum from liberal to conservative, and I took a subset of those news sources. GDELT is now available in Google's cloud platform called BigQuery. It is not only a data warehouse for enormous data sets, but also you can run analytics right within the database with queries so that you don't have to pull all the data that you're interested in out and do analysis on it outside of the system. You can use the web UI that BigQuery provides to look at information about tables, including a preview of some of the data that's in there. And you can also execute queries through their UI. It's very nice. You can see things like an explanation of how long it'll take, the breakdown of time for a query. You can get a preview of how big the query is going to be, which is important because you get charged for large queries, or for queries, but you get charged a lot for large queries. However, instead of using that UI, I ran the code, I ran the queries from R, and I have the code so that if you want to run it yourself, you can. And in order to do that, you would need to set up R on your computer, make an account at Google BigQuery, make sure that it works for you, and then open the code that I've provided and run it in R. You'll start by doing an example query to see if you can get a visualization that looks like one that was published on the web. And this is about the the amount of articles that mention the country Chile over time. When I run this code, I do get a graph that looks quite similar to the one that was published. My starting point for the work that I did was an article talking about Turkey's stability in 2015 when there was a lot of unrest. And the author used GDELT to assess whether or not Turkey was heading for civil war. And these are a couple of graphs from that article. They looked at the amount of material conflicts there were, clashes between the government and protesters, and there was a big spike in August of 2015 or late July, but over time there were fewer and fewer reports of clashes. And so the author concluded that we weren't heading for civil war in Turkey. However, he did point out that anxiety levels remained high. So I took his query and modified it for my purposes. Specifically, I wanted to be able to pull back the source, so the publication, and I wanted to get a count every day. So here's a couple of the sources that I included, and this is what the result looks like. So I have my day and month, the source, a number of articles, a measure of tone, and then what I care about is the number of words that are related to anxiety and the total number of words in that article. And so my measure is to divide this column by this column. Here's an example result where for the publication MSNBC, or the news source, you can see over time what is the anxiety level. And here you can see, for example, that the largest peak in anxiety in the articles comes immediately following the 2016 presidential election. I was also interested to know whether baseline anxiety differed between publications, and in fact it does. So Breitbart, for example, articles there have many more words relating to anxiety than do Bloomberg or Wall Street Journal. And then this was my final visualization. It's a heat map where red is high and blue is low for the anxiety score. The x-axis are different news sources, and the y-axis is time. And there are 3 years that are covered, 2015 through 2017. Actually started partway into 2015. And you can see some things. So for example, there's a lot more red down in 2017 for many of these news sources. So perhaps 2017 is a nerve-wracking year compared to, say, 2015. But you can also see in late 2015 a big spike in anxiety levels across all of the news sources. And this came immediately after the terror attacks in France on the nightclub. Similarly, you can interpret some of these other peaks if you dig into the news articles behind them. So the lessons that I learned in carrying out this project include that you need to be careful when you're querying because you can run up some costs. So you need to use the tools that Google provides to estimate the size of the query and therefore the cost before you actually run it. Also, I learned that it's important to dive into the details, so you might start to make some conclusion with high-level querying across all of the automatically generated metadata on these articles. However, it's important to dive into the details because when you look at which articles are actually contributing to, say, a high anxiety score, it may not make sense, and there might be some simple reasons why you shouldn't trust it on the face. So while it's good to do some of these high-level queries, it's always important to do at least some spot checking to make sure that it makes sense in detail. So thanks for listening. I will have another video where I actually walk through the running the code, so look for that. Thanks. Okay, now we're going to actually look at how you can use BigQuery on the web and then from R. So here I've gone to bigquery.cloud.google.com. I'm already signed in, so I can look at my query history. Oh, there it is. And click on one of the queries and open it up. So this is a really nice interface. You can do things like, this is a little validation tab, and it'll tell you how big the query will be, so therefore how much it will cost you when you run it. And this is a very small and simple query, so you can run it without any problem. It takes a few seconds and it comes back with the answer. So in this case, I've asked how many events there are. There are 304 million of them. Now let's go over to RStudio, where I have an R Markdown file that you can run. So I'll just start evaluating sections of this oh, I guess I haven't installed everything on this computer. So if you need to do that in RStudio, one way to do it is with Tools, Install Packages. And that may come up a couple of times here. So I'm going to stop and install them. Okay, so I have now installed the packages that I need, and they all will load. All right, so the first thing that we're doing is to set up that connection with BigQuery, and I've already, I might not have done it on this computer, so we'll see how that goes. So this is my code to actually run a query. So query exec is the function from the big R query package that I use to run a query. But I have a lot of other stuff in here to cache the results so that I don't run a query twice and thereby incur costs that I don't need to. So let's see how it goes. We're going to test it out with a very simple query. And it seemed to have worked, indeed. So we'll go on and do this query about Chile. Now we're running it, and we have a cached result. Here's what the top of the data set looks like. I have a function to make a graph, and then here's the graph. Great, okay, so now I have different sources that I'm going to be interested in. List them there, and I've just taken a score about their ideological position on a one-dimensional graph from that publication I mentioned earlier. So now I have some code to actually do the query, the big query that I want to get. And I'm not sure if that will solve my problem. Library cable extra. That's it. Great. Okay. So now I do various manipulations in order to get the data into a format where I can make a nice graph of it. And here we go. So here's that bar plot showing the anxiety level for various publications. And I also have this more complicated box plot, again showing that the different anxiety scores really are significantly different from each other. And then I can compare anxiety and ideology, and then plot scores over time. Here's the MSNBC graph. And then I can make the heat map. And this takes a little bit of time to render. Mainly, I think, because well, I don't know why. Anyway, here it is. And you can see here are the different years color-coded. Time goes from top to bottom. And there you have it.